Good morning, everyone. It's great to be back here on the Columbia stage and to talk to you today about the most important tech company you've probably never heard of. Now, Groq, Jonathan, welcome to the stage. Before there's any confusion in the audience, you do not run the company that's a very chatty chatbot created by Elon Musk. Am I right?
Never met Elon.
Exactly. So this is not the Groq that some of you might be thinking of that ends with the letter K, G-R-O-K. This is G-R-O-Q. And in fact, in preparation, and this has been a point of some contention, your Groq was created many years before Elon Musk came along. And of course, they're both inspired by a wonderful science fiction novel, A Stranger in a Strange Land. We'll talk about that maybe a little bit later. But in preparation for this gathering, I did ask Elon's Groq, which has been quite chatty and quite snippy about Elon Musk himself lately. Some of you might have seen in the news. I asked, what do you think about this other Groq? And interestingly, I thought I'd share with you, I get why your Groq might feel stepped on. They were there first. And Q or K, it's hard to miss the echo. So an apology is passed on to you from the other Groq. I thought that's a good way to start. Now, your Groq makes specialized AI chips, just for those of you who might not yet be in the know, known as language processing units, LPUs. Which, unlike the ones that we're all familiar with, NVIDIA's chips, these are made to run specifically these large language models. And so you do it with very little latency in comparison, much faster and much less energy use. And so we'll talk a little bit about that, how and why this technology is very interesting. And again, we're here at an energy conference. We're going to talk about energy. We're going to talk about geopolitics. You have a particular view on where that's going to go. One other reason why you might want to pay attention to this company that you might not have heard of, he has a valuation, last I checked, of some $2.8 billion for his startup. So just so you know, it's one to watch. With that, let's get a little bit of your journey. You were integral to designing the tensor processing units, the TPUs at Google. And at some point, you decided that you were going to head in a different direction to create this company, to pursue this technology. Give us just a little bit of insight. We'll start with the technical, so we're all on the same page, and then we'll jump into the topics of this conference, of course, energy, geopolitics, and where we go from here, the future of AI. But tell us just a little bit about how you got here.
All right, and just to make sure everyone can hear me, so good morning. Come on, we can do better. Good morning. All right, you can hear me. All right, so I started the Google TPU. That's the AI chip from Google. And after doing that, I started getting a bunch of calls from competitors of Google asking, could I create something similar for them? And the reason that some of them gave was, well, it's not good for the world for Google to be the only major tech company with their own AI chip. And I started thinking about it. I'm like, they're right, but the problem is two major tech companies having an AI chip advantage isn't much better than one. So I decided to go out, create the LPU, and make it available for everyone.
And what is the insight that led to the LPU? And how did you know, or how did you have the instinct that latency was going to be an issue, that large language models were the way to go? How did you solve that problem?
So I think your phone is jumping in there. Maybe it needs to use LPUs.
Maybe Groq is listening in, the other Groq. Yes, okay. Go on. Yes.
So the big insight was actually AlphaGo. About 30 days before the competition with DeepMind, we got an email from the DeepMind team saying, we just played a test game against the world champion and we lost. We lost badly. Is your chip as fast as we've heard? And we replied, yes, that was it. And so that began a 30-day sprint to port the software over. The interesting thing is we didn't retrain the model at all. We just moved it from GPUs to TPUs. And what ended up happening was Lee Sedol played that first game. He was incredibly surprised by how soundly it beat him. And in the second game, there was this move called the shoulder hit. Famous move now, very creative. Everyone's like, I can't believe a machine came up with this. It was a 1 in 10,000 game move, but what happened was the GPUs couldn't search deep enough because they weren't fast enough, whereas the TPUs could. They found it, they played it out a little bit, like sort of playing it out in your mind, realized it was a good move and played it. When we tried on the GPUs later, they never once found it. That was the insight. And Go and LLMs are pretty much the same thing. Instead of a sequence of moves, though, it's a sequence of tokens. And because you can't produce the 100th token until you produce the 99th, it's a very similar sequential problem. That was the insight. But as for our architecture, and this is going to matter a lot for energy policy, One of the observations that I had at Google was, yes, the number of transistors were doubling every 18, 24, whatever months. That's Moore's law. But we had another observation. The number of chips were also doubling at the same rate. That's a 4x increase in compute, not a 2x. And so the question we asked ourselves was, if the number of chips was doubling, is there a different architectural approach that we could take if we assumed there would be an infinite number of chips? And so that's what we took advantage of.
And so you don't use high bandwidth memory, am I right, HBM?
Correct.
And this helps in the reduction of latency, which is a huge issue.
If you have an infinite number of chips, rather than storing some of the data externally to the chip in memory, you just lay it out across a whole bunch of chips, sort of like a big factory where things just flow through. And to understand why this is so important, because compute uses energy. Well, why does it use energy? Well, the length of a wire times the width of a wire times the voltage determines, or the voltage squared, determines how much energy you use. When you have a chip here and you have memory here, you have to go down, over, and up. But when you're inside the chip, you don't have to do that. The wires are smaller, so we use about 1/3 of the energy per word or token that's produced.
Now, that's a significant claim. It's been validated by outside testing. But I believe there's a particular thing we need to understand about AI as well. A lot of the focus has been on these training models, right? It takes a lot of energy to train.
Yeah.
But you make the argument, and as do others, in fact, after models are trained, the lion's share of the energy that's going to be consumed by AI models is actually when you use it, in the inference. And that's what your focus is on. Am I right? That the actual application in inference, and that's where you find an advantage in the application of your technology.
So I would say that AI is not an information age technology, because information age technologies are about retrieving data and making it available to a user. You're reading from a hard drive, you do a small amount of compute. Llama 2, when it was trained, Meta's model, their open source model, it cost about $4 to $5 million of compute to train it. However, the amount of data used would actually fit on this phone, and actually if you were to transmit that data over the cell phone's wireless plan, as jacked up as that price might be, it would be in the tens of thousands versus 4 to 5 million. So we're talking about a 100x cost differential between compute and data. You send 2 bytes over to the AI model, it does 140 to 180 billion operations, and then it sends you 2 bytes back.
So that sets the stage a little bit, because we understand you have a different approach. You're focusing on where, over the lifetime of an AI, most of the energy will be consumed. And reducing that energy will certainly contribute to some of the energy challenge. But let's take a step back. Let's delve into the topic of the day. There's been a lot of alarm bells rung about AI consuming half the world's resources, about the amount of energy that'll be consumed. Equally, and we'll see a major report from the IEA released tomorrow, early morning Paris time, that I encourage all of you to look at. I've had the chance to read it on embargo, and I won't reveal any secrets other than to say that the IEA's position has been for a while that AI will not consume half the world's resources. It might be air conditioning or other forms of electrification, is to sort of calibrate one's argument here. But where do you come from on this question that AI will consume enormous amounts of energy resources, and what good is it actually going to do, as yet unproven? How do you respond to that?
Predicting the future is fraught with peril, but I will make an argument, and the argument is this. We have a stack up in civilization. We started off with materials, so Stone Age, Iron Age. Then we moved into the Industrial Age, where it was all about energy. Then we moved into the Information Age, where it was all about data. The difference between the Information Age and the Generative Age is that the Generative Age it does computation, it does answers contextual, novel answers specific to your question, and that requires compute. And if you think about it, we've been able to pull more energy out of the ground. It's hard, there's a limited amount of it, it's hard to find, but we spend more money on it, we get more energy. We haven't been in a place where we could just spend more money and get more intelligence as a civilization. We've just never had that ability before. So now we're facing population declines, we're facing all these other issues. If I tell you that you can take $1 billion and put it into producing the equivalent of $1 billion worth of human output or more, would you be willing to do that? What happens when the intelligence gets better? What happens when it's 2x as good, 10x as good, because it just keeps getting better? So people are going to want more of it. And Whereas with air conditioning, for example, there's a finite amount of value to that air conditioning. It's just keeping things cool. With intelligence, if you can keep pouring money in and getting more intelligence out, will you ever stop? So you go back to the doubling of chips, that's exponential. There's any amount of energy you want to spend on AI, you just have to look out a certain amount of time and we'll get there.
So I'm going to push back a little bit. That first of all, on the question about air conditioning, the Singaporeans would argue without air conditioning, their society wouldn't exist. So it has enormous value in warm cultures, especially as increasing heat waves come. It may be an existential question whether you have adequate heating or cooling. But leave that aside. There's a sort of a deeper challenge I want to put to you, and that is what you're calling intelligence. What is the value created, right? There's a difference between invention and innovation. And a difference fundamentally I've argued over the years, including in my most recent book, Need, Speed, and Greed, available at good bookstores near you, about the future of innovation. The difference is innovation is creating value from an invention or a fresh way of thinking. Just because we have what you call intelligence doesn't necessarily mean we'll be able to put it to productive use. Robert Solow, the great Nobel Prize-winning economist, once observed about internet technologies. We see it everywhere except in the productivity data, right? It took many, many years, and indeed decades, before we saw the benefits of the internet actually turn up in things that could be measured. And so what if we do, as you propose, massive amounts of quote-unquote intelligence, but we're not able to harness it in a useful way to enhance humanity or to create economic activity? Is it still worth it? Is it still worth the energy?
So let me step back a little bit. I refer to it as where we are now as the generative age instead of the intelligent age, as some people are doing, because I actually don't think we have the equivalent of human intelligence, and we're a couple of steps away. And if you go back historically, when the calculator was invented, the immediate reaction was, oh my gosh, machines are going to be able to think like humans, because up until that point, machines had never done arithmetic before. Then we beat the chess champion. Then we beat the Go champion. And now it speaks to us. And every time we see AI do something that, or computers do something that was previously human only, we think we're just one step away. We're actually a couple of steps away, right? These things are not innovative. They don't invent things right now. They occasionally stumble upon something interesting, and you have to recognize that because they don't have long-term memory. But here's the thing I want everyone to keep in mind. The rate of change is dramatic, right? AI was moving pretty quickly before everyone thought, oh my gosh, this is going to be the next big thing. Just imagine if at the start of the information age, when they invented the printing press, someone from the future came by and said, yeah, this is going to result in this smartphone here. There would have probably been a lot more investment in it because people would have seen where it was going. We are that smartphone for generative AI. We know where this is going. We know what the value is. So you're seeing all of this money being poured in as a race to not lose. What's going to happen, though, is all of that compute that's being built out, and there is a lot of economic results. All advertising, for example, is done through AI. So the Mag 7, most of that is coming from AI, right? What happens when all of that compute that's been deployed, all of those AI models get upgraded with the ability to do invention because we figured that out algorithmically? Now, all of a sudden, all of those assets that have been deployed are going to become significantly more valuable overnight.
Your desire, I think, stated previously, is to try to reduce the cost of compute close to zero. Am I right? At least asymptotically. What do you say about the Jevons paradox or the Jevons effect, the rebound effect? I know you were talking about it years before Satya Nadella woke up to it and sent out his famous tweet. People in the energy world know it in this room, I'm sure intimately. We've talked about it for decades. When energy prices go down, people use more gasoline, they drive more, et cetera. But as it relates to this junction between AI and energy consumption, are we not going to see the offsetting of whatever gains? I think you said your power maybe 1/3 that of comparable approaches. Wouldn't that be overwhelmed by this rush to use the new technologies thanks to Jevons paradox?
So we don't yet have models that can invent, but we will at some point. Maybe it's 5 years, maybe it's 10 years from now. And what I want you to think about is, what is the energy cost for a unit of intelligence? Well, first of all, what is a unit of intelligence? So we know how to measure energy and power. It's megawatt hours, it's megawatts, right? Those are energy and power. For intelligence, the unit of measure is megatokens. A token is kind of like a syllable for AI. You can almost think of it as a word, but there's megatokens per second, and then there's megatokens, which is what we bill for. Now, if I can produce a mega token for less energy from AI than I can from a human being, and if I can scale up the amount of intelligence that I need, I can look at the base load of energy that humanity is using, and I can say, maybe if you have human beings trying to solve the energy crisis, we're not going to get there before we boil ourselves alive. But maybe it makes sense to quickly add some more intelligence. Now, one of the things that I think people have a little backwards here is they generally think that it takes more energy for an AI to produce a result than a human being. So let's make it very concrete. A novel is about 80,000 of these tokens in how they correlate between words and syllables for the AI. If I was to do that with our chips, it would take about 40 seconds to generate.
You trying to put me out of business here, pal?
It's not going to write as well as you, yet.
Well, thank you. Yes.
Yet.
Okay.
Yeah.
We'll see.
Okay.
We'll see. Yeah.
But now, if I can generate that in 40 seconds, I've done a couple of things. One is I actually didn't use as much energy. Like, how long would it take you to write a novel?
It takes me about 500 steaks, a couple of beers,
500 steaks, that's high stakes. Okay.
Yeah.
So a lot of steaks, a lot of beer,
calories,
a lot of calories.
Yeah.
But I could probably so if I do that in 40 seconds, I'm probably using somewhere on the order of about 80 kilojoules. That's not a lot of energy. Now, the quality of the models aren't there yet, but when they can invent, and it takes a little bit of energy to do this, you could start seeing us solving problems for less energy with AI than we can with humans, and it might be the only way to get to those things.
But surely, you can't compare apples with oranges, right? There'll be some range of tasks where we can do task shifting, where AI will do things better, more efficiently, as you rightly point out, and we will need to shift to higher value-added tasks or differentiated tasks where we can do it better. Whatever the amount of energy we consume, the AI can't yet match us or may never match us. Is that fair to say?
I would find it hard to believe that it would never be able to match us, but I will say there's another thing here, which is AI is probably going to make humans smarter. And the reason I say that is if you look historically over the last 100 years, human beings have gotten a lot more intelligent. And one of the great things about us is we have language. So just imagine if you grew up in a cave, not exposed to anyone, you wouldn't be nearly as smart as you are now. AI is going to make us smarter by generating interesting insights, information. And what we're going to do is we're going to filter those insights, and we're going to share them with each other, just like we do when a human being does it. And we're going to start getting smarter as well.
Right. Jonathan, I'm going to pour some geopolitical cold water on your techno-utopianism here. Jason set us off on the right course by framing the discussion. This is a day in which we saw massive tariffs imposed at 12:01 a.m. By the United States. But we're in the context of a world of deglobalization, of fractures, of geopolitical tensions rising. In this kind of context, I want to come to your particular vision for how you think AI should be made. And you have a very interesting perspective that's different, perhaps, than some competitors and others in this area. You think that rather than having the making of AI, as it were, spread like jam all over the world, that we should make AI, or we should build AI where energy is and where it's low cost. In maybe a half a dozen or so places in the world. And to put your money where your mouth is, you actually bet on Saudi Arabia, which has invested, I think, $1.5 billion, if I'm not mistaken.
$1.5 billion this year,
very recently, and you've built out in cooperation with Saudi Aramco in Dammam, where I was a few months ago. They have a massive bet on AI. So you've placed your chips, as it were, there. That's obviously a place where there's a lot of energy. Tell us about this vision for creating AI in a few places, and what people might say there might be latency in getting that information to where it needs to go. You have a contrarian view on that as well, in my perspective. Tell us what that view is.
I think to make it very visceral and simple, there's a reason why call centers can exist in India and service North America. The latency for speech is not that acute, right? You can get away with that sort of round trip latency as long as the AI is fast enough in generating the voice. And this is a little bit different from typical information age technologies. The more it's voice, the further away it can go. And also there's a whole reasoning component, and all that can happen locally. So my expectation is you're going to see major centers of compute popping up around the world. I think Saudi Arabia will be one of them. I think Canada and North America will be another one. And you'll probably see
We're
a couple
energy
of
abundant,
other.
remember?
Exactly. Well, it depends on your definition, but yeah, I mean, it's there. It's just not all necessarily connected up into data centers. Please fix that for us.
I think people today will have some views on that, but continue. So you're going to see half a dozen or so places in the world that are clusters, is what you would like to see. And you think this makes sense?
It makes economic sense. The one thing that we see a lot of, though, is everyone wants to keep their data local. They want to have sovereignty over it. And people still haven't made the leap in their head of the difference between the information age and the generative age. 2 bytes of data in, 140 billion operations, and then 2 bytes out. We do not store any user data. People just send us a query, we do the compute, and we send a result back. And that's a huge shift in the way that this works.
One of the questions that's raised, and the Saudi connection makes this more poignant, that as we scale up AI, especially dramatically scaled up in your vision, will it be fundamentally a fossil fuel play? Will this be essentially fossil fuels that will power AI? And if so, doesn't that bake the planet? Another one of the concerns today is really to think about concerns about climate change. How do you answer that? Is it worth doing? Is it worth making the AI if it involves burning more fossil fuels because of all of the extraordinary gains that you posit will come to humanity, that extra intelligence? Or is this something where we need to take extra care? There should be either regulations or rules or safeguards to prevent that incremental burning of fossil fuels to make the AI.
Let me go back to what I said earlier, but I'm going to do it as sort of an image. If any of you have been in a really old home, like 300 years old home, you know the AC is terrible, and if you put a bunch of people in the rooms, it starts to warm up. There's no airflow. That's kind of where we're living now, right? And so we're there, we're on a treadmill, we're running, and we're heating up that room, and at some point it's going to get intolerably hot. Now imagine you have the ability to bring in a super fit athlete, and your goal is to run a certain amount of distance. That super fit athlete is going to burn less, they're going to consume less oxygen, they're going to produce less heat. They're just more efficient. And if you can get a bunch of them in there and run those miles quickly, you might actually be able to solve the problems before you overheat. That's really it. Is AI more efficient at solving problems from the energy consumed for the output? Because we're going to be consuming an amount of energy just living. That's going to happen. So does it make sense? And here's the other thing. We're going to be doing all of these non-climate change related things. With AI, if it became acute enough, we could just say, okay, take all of that compute, focus it on climate change. That's the most acute need that we have.
And there are certainly, to be fair, there are a huge number of applications in which AI is already showing promise, whether it's climate modeling, weather forecasting, making energy grids better. There's a package written by a team of us at The Economist I recommend to you in this week's issue coming out that looks deeply into the applications of AI in energy and environment. We found numerous examples already that are quite promising. So I see where you're going with that.
Let me add one more counterintuitive thing here, which is when you're talking about people and having them do some sort of economic activity, think about how long it takes to train people to gain that expertise. When you have an AI model that learns a certain task set, you can then make as many replicas of that as you want. So you can very quickly change the economic activity that AI does much quicker than you can humans.
What about the question I started with, that is the geopolitics, the tariffs, the supply chains? How much will you, just to take your own company, how are your supply chains going to be hit? People are concerned about other tech companies being affected. Can you give us a little perspective on that? How will geopolitics affect you?
Okay, so right now there's an island in the South China Sea where there's a whole bunch of focus and military effort. And so why is it that two world nuclear superpowers are at odds with each other over this island? Why are they risking nuclear war? And the answer is chips and AI. And the reason why China has focused so heavily on AI is that they realize their biggest advantage is numbers, the number of people. The fact that they have over, 1.4 billion people who are under their control and they can direct however they want. And in the US, we don't have anywhere near that population. AI disrupts that because now in the US, we could just start adding the equivalent of more people with AI, even if it's just a multiplier for the people we have. And if they can't do that, we could catch up and surpass them. And then the real fear here is that there's a breakaway. You get to a point where no one can ever catch up with you again. And so this is very politically destabilizing. There is a race, and it feels as if you win it permanently. There is no catching up. It's not like the information age where you get to learn from all this. Like China had all these factories, and they learned from the US. This is going to be very opaque. You're not going to see what's going on inside of the AI. You're not going to be able to do as much espionage. You're not going to be able to steal as much data because it's inside. You can't just hire the AI away. And so this is a life and death moment for some superpowers right now. Now, we fabbed our chips in the US, even though we started in 2016.
Your entire supply chain is in the US?
Our chips are in the US. We package in Canada, package the chips. We assemble our cards here in North America, actually in California. And then we do half of the systems that we assemble in California and half in Mexico.
And if I understand, you've shifted to a cloud model. So other than for perhaps the US government, you will offer a bundled service rather than selling chips.
Sort of like AWS. You just go there, you rent compute.
Okay.
You don't
we have just a couple of minutes, so I want to take. I've been given a question from the floor. It's quite specific, but what do you think about the potential for web AI, as someone from the floor, which Apple recently partnered with?
I actually don't know what web AI means.
Okay, sorry. You'll have to look it up on Groq, I guess. Let me come back to my question then.
This Groq.
We have just your Groq, exactly. Your
we
Groq.
got dibs.
In just actually on China, I want to sneak in one more question. I was our bureau chief in Shanghai there before, so I would challenge your idea that it's only about chips that China is interested. They have a deeper political philosophy as to why Taiwan is part of the mainland. But leave that aside. The question I have is about the DeepSeek phenomena or frugal engineering, that it's not simply first past the post, that winner take all necessarily. We have seen a challenge to that concept. We have seen not only with DeepSeek, but the idea of alternative pathways, other ways of innovation in this area that pose challenges. There are other chip companies that are trying to do what you're doing as well. The NVIDIA might not be as invincible as some people think. So give us an idea, or make the case, if you don't mind, of what might be another pathway to the future that might involve other kinds of innovation.
Well, just starting off on the NVIDIA point, NVIDIA is amazing for training models. That's the creation of them rather than running them. We recently passed 1 million developers on our platform. For comparison, I think NVIDIA claims 5 or 6 million, but they did that over like almost 3 decades. And in our case, we were able to do that in less than a year. The reason is it's a completely different demographic. We would be shocked if even 5% of the people that are developing on us have ever trained an AI model. These are web developers, trying to make it little web AI. I'm not quite sure what that term means.
Yeah.
And so they're just building things on top of us, right? So that's a complete disruption because it's a completely different audience and group of developers. But then when it comes to DeepSeek and the models like these, one of the things that we're seeing is that you can distill existing models. So you can take general intelligence and you can replicate it with a smaller amount of compute. So just to make it very specific, you can measure roughly the expense of running a model and the number of parameters. It's almost like the number of neurons in a human brain. And this is one of the reasons that I'm going to argue that human beings can get much smarter, which is when GPT-4, OpenAI's first high-quality model, was released, it was 1.7 trillion parameters. A little bit later, less than a year, an 8 billion parameter model, so 8 versus 1,700 in size, actually outperformed it in quality. So it turns out you can distill these big models, once they learn a bunch of information, into a smaller model and make it cheaper to run.
Jonathan, I'm going to give you 1 minute to reflect on the vast potential of AI to transform humanity itself. You've talked about how large language models are the telescope for the mind, I think is the phrase I've seen. Subtlety, nuance to human discourse. You've spoken in really poetic terms about the potential. And yet, one of the great godfathers of AI, Jan LeCun, has argued that these large language models, which you focus on, may be obsolete or nearly obsolete within 5 years. And so give us your sense on that debate, and where does AI take us? 60 seconds, go.
So I apologize. I dropped out of NYU, not Columbia. My mistake. Jan LeCun is a technical advisor for us. We have this debate all the time. So let me first start off with AI and whether or not you should be afraid. I think a couple hundred years ago there was this guy Galileo, and he popularized the telescope, and he got in a lot of trouble. And he got in a lot of trouble because he pointed it up at the sky, and he made some observations about how the universe was much larger than we ever anticipated, and it made us feel really, really small. And I think AI is very much the telescope for the mind. as LLMs get better and better, and they're getting better at these human tasks, it's starting to make us feel really, really small. But I think over time, we'll get used to this concept, and we'll start to realize just how vast and capable intelligence is, and we'll see the beauty in it.
Jonathan, I'm going to stop you there, because that is both a poetic moment to end on, a reminder of our humility. As Carl Sagan reminded us when he saw that pale blue dot, the Earth as seen from the edge of the solar system, he said, remember, we are one. There's one pale blue dot. And that humility is something that's powerful to hear from an AI enthusiast and advocate. So please join me in thanking Jonathan for sharing his insights and getting us off to such a great day. Thank you. Enjoy the conference.